Hello and welcome to lesson 2.5. Today we're going to look at properties of numbers. Now most of these should be a review, however we're going to go through them and there are a couple slides of these, so I do apologize, this will be a little bit tedious. To begin with, let's look at the commutative property of addition. Commutative means that we can switch the order, so I have A plus B equals B plus A. So if you want to look at a numerical example, 3 plus 7 is really the same thing as saying 7 plus 3. Likewise, when I look at the commutative property of multiplication, A times B is really equal to B times A. Numerically, that's like saying 3 times 7 is the same as 7 times 3. On the other hand, we have the associative property of addition, and this is where if I'm taking three quantities and I'm adding them together, or more, okay, it means that I can group them in any order and still get the same end result. So I can either take the first two terms and add them together and add them to the next term, or I can take the first term and add it to the sum of the second two numbers. So how this would work is, if I look at the numerical example here, I can say 6 plus 4, which is 10, plus 5 is 15. So I have 10 plus 5 equals 15. But if I look at the top side of that, then I would say I could take 6 plus 4 plus 5, which is 9, and this is still going to give me 15. Likewise, when I look at the associative property of multiplication, it's kind of telling me the same thing, that order doesn't matter. I can take the first two terms and multiply them together, then I can multiply that answer by C, or I can multiply the second two terms together and multiply it by the first one, and I'll still end up with the same thing. And again, you can see that over here on this side. Next, we have the identity property of addition. Now the identity, the way you need to think about this is, remember, an identity is like it stays the same or it doesn't change. So for the identity property of addition, you have to say, what can I add to something to where it does not change the end result or does not change that original number. So in this case, I can add 0 to any number and I still get that original number. So numerically, I can say 9 plus what will still give me 9, or I can say 9 plus 0 is 9. Likewise, when I'm multiplying, I think to myself, what can I multiply A by to still get A out at the end? And the answer to that is 1. So the identity property of multiplication is going to be to multiply by 1. So 6 times 1 equals 6, and that's because 1 is the identity property of multiplication. Next, we have the inverse property of addition, and what this says is for every essentially positive A, there is an additive inverse, which is the opposite of A, such that A plus the opposite of A equals 0. So here we can see that 5 plus a negative 5 will also give me 0. The inverse property of multiplication says for every A, other than when A is equal to 0, there's a multiplicative inverse, which is 1 divided by A, such that when you multiply A times 1 divided by A, you end up with 1. So the inverse property of multiplication with numbers in it looks something like this. So if I have 5 times 1 over 5, which is really the reciprocal, this is going to give me 1. Then we have the symmetric property that says if A equals B, then we must also know that B equals A. So I could say 2 times 3 equals 6, so that must mean that 6 equals 2 times 3. It goes both ways. And finally, we have properties of our real numbers. Okay, so we're assuming that A, B, and C are all real numbers. We have the distributive property. Okay, and with the distributive property, this says that if I have A times the quantity of B plus C, we can distribute that A and multiply both B and C to get A times B plus A times C. So if you notice on the numerical side, I can distribute this 5 onto 4 plus 2, and that becomes 5 times 4 plus 5 times 2. Likewise, I have the same thing if I'm subtracting. I can distribute that A onto everything inside of those parentheses because I'm subtracting, and then I end up with AB minus AC. And you can see the same thing is true over here on the numerical side. We also have what we call the multiplication property of 0. And this says that for every real number n, that number times 0 is always going to equal 0. And it works for negative numbers, positive numbers. So negative 35 times 0 also equals 0. And we have a multiplication property that deals with negative 1. So for every real number n, negative 1 times n equals negative n. Okay, now another way you can think of this is that negative 1 sometimes is nice to think about it as being the opposite or changing the sign. So if I have negative 1 times a negative 5, I'm going to change the sign of this n value, or in this case a negative 5, and it will become positive. But if I had something like negative 1 times a positive number, then it's going to change that to a negative 5. Now when we look at example 1, we're going to list the property that is used. Notice I have 9 plus 7 is equal to 7 plus 9. So because I'm just changing the order in which I'm adding, this is called the commutative property. So I'm going to put commutative property. And because we're adding, it would be of addition. Okay, now for part B, it says that I have D times 4 in parentheses, or it's the quantity of D times 4. Then I'm going to multiply that answer by 3, and that's equal to taking D and multiplying it by the quantity of 4 times 3. So because I'm multiplying, I'm changing the order in which I multiply, we call this the associative property of multiplication. Okay, part C says I have T plus 0 equals T. Well, T, I start with a T, I add something to it, and I end with a T. So that means I get the identity to withhold itself. So this would be the identity property of addition. Okay, and finally, when I look at part D, I have a negative Q equals negative 1 times Q. So because I'm multiplying by a negative 1, this right here is considered the multiplication property of negative 1. And example 2 is similar to example 1, so I would suggest that you pause the video, try to do this on your own, and then come back and double check your answers. So for part A, we're going to name the property that each equation illustrates, and then we're going to explain. So I have 1 times m equals m. Because I am multiplying m by something and getting m out at the end, this right here is going to be the identity property of multiplication. For part B, it says the quantity of negative 3 plus 4 is going to be added to 5 equals negative 3 plus the quantity of 4 plus 5. Well, here I'm just changing my grouping symbols and grouping different terms in a different order before I add. So this would be considered the associative property. And because we're adding, this would be of addition. For part C, we're multiplying. We have the quantity of 3 times 8. Then we're going to multiply that by 0. Or we can say 3 times the quantity of 8 times 0. So because I'm shifting what I'm multiplying first, this right here is considered an associative property. And because we're multiplying, this would be of multiplication. Now for part D, we have 2 plus 0 equals 2. So I start out with a 2, I add something to it, and I get 2. So this tells me that I'm maintaining the identity. So this must be the identity property of addition. For example, E, we have n times p equals p times n. So we're just changing the order in which we multiply. So this would become a commutative property of multiplication. And finally, we have P plus Q equals Q plus P. Again, we're just changing the order in which we're adding. So this here would be considered the commutative property of addition. Now, sometimes we have to use what we call deductive reasoning. Deductive reasoning is no more than the process of reasoning logically from given facts to a conclusion. So it's kind of like the justification piece, or explain why you're doing what you're doing. So we'll see how this works here in the next example. Example 3 says that at the supermarket, you buy a package of cheese for $2.50, a loaf of bread for $2.15, a cucumber for 65 cents, and some tomatoes for $3.50. We want to find the total cost of the groceries. So in order to find our total cost, we are going to have to add these together. So we're going to have our cost equals, we have $2.50 plus $2.15 plus 65 cents plus $3.50. Now, if you're at the store, you're probably going to use mental math to do this. And to do mental math, I would probably take this 250 and 350 and add them together. So I would do something like 250 plus 350, because that will give me a nice number. Then I would probably add that to my $2.15 and then my 65 cents. So by doing this right here, I have just performed the associative property of addition. So this is my deductive reasoning that I just did, because I grouped two numbers that were going to be easy or easier to add. So once I did that, then this is going to give me 250 plus 350 is $6. Then I still have to add that to my $2.15 plus my 65 cents. So what I'm doing here then, if I had to justify it, would be to add within the parentheses. So within the parentheses. And then what I'm going to do from here is I'm going to simplify and add 6 to 215, which is going to give me 815 plus my 65 cents. So I can see that I'm going to spend $8.80. And what I did at this point here is I simplified. So my deductive reasoning would be to simplify at this step. Please let me know if you have any questions. Otherwise, have a great day and we'll see you in class.